Hello. Okay, let us move on to the next problem. It's a sixth problem. Let me start on the timer. Okay. Yes. Okay. An object of mass 2m. So this mass is given, velocity is given, stationary mass. Okay, this is a problem on collision. So I have two objects, one of mass 2m moving at a velocity 3v plus another mass 4m which is initially at rest. So this will now give rise to what? Both objects will stick together and start moving at a velocity v dash. So now we can apply the conservation of momentum. So though it is an inelastic collision, still you can apply. Okay. So which should now be equal to 2m into 3v plus 4m into 0. Sum of the initial momenta should be equal to final momenta. What is the final momenta? 2m plus 4m is 6m. 6m into v dash, right? So 6m into v dash. So therefore, now if I do this, I get 6mv should be equal to 6mv dash, or v dash is equal to v. Okay. Next, let us find out what is the change in kinetic energy. So how do we find change in kinetic energy? Which should be kinetic energy final minus kinetic energy initial. Okay. So which should now be equal to what is kinetic energy final? Which should be half into what is the final kinetic energy? 6m into v square minus what is the initial kinetic energy? Half into what is the first one? First mass 2m. 2m into 3v whole square, which would be 9v square minus plus what is the this kinetic energy is 0 because it was not moving. So which now be equal to half into 6mv square minus 2m into 9v square. How much is it now? This should be 18mv square. So which should now be equal to 18 minus 6 should be 12mv square. 12 by 2 should be equal to 6mv square, right? So the answer should be 6mv square. So the answer is V and 6mv square, which is the answer. So we have taken more than 2 minutes, but in order to explain, I need to do this. Thank you for being patient. Okay, let us move on to the next question.